Good morning, students. You go ahead and pause the video here and then do the objective and then do now. Unpause when you're done. Alright, so as you can see, you're going to continue talking about the periodic table today. You're going to talk about electronegativity and atomic radius. So you should have said that number of protons just increases as you go across and down the periodic table. That's actually how the periodic table is organized, is by atomic number. And then number of shells is the periods, which is the horizontal ones, right? So first row has 1 shell, second has 2, third has 3, etc. Oh, what's that? It's a picture of a baby. Cool. Alright, so you can go ahead and pause this video and go to the video lecture. You want to be open to page 3.5, and you also want to have probably some paper out to take some notes on. So you can search this video title to find it, and it should come right up. So go ahead and pause this video. Okay, I hope you enjoyed that exciting lecture. And now you're going to do a reading to help cement what you just went over in the lecture. So you're going to read page 7 to 10, so that's 4 different pages. Why don't you do partner reads on each page, so take turns reading to each other. For the ones that are graphs, I just want you to annotate the graph out loud to each other. After each page, do the check for understanding, and then you can play the video for answers. So if you and your partner are moving faster than the class, that's okay. Just move on to the next page. And after, I don't know, 3-4 minutes a page, maybe 5, the interim teacher can play the check for understanding answers, and I'll go over those. Alright, so this is the first test your understanding, check your understanding. So go ahead and do that first page, pause this video, and unpause it when you're ready to go over this. Alright, so on that first video, as you move to the right on the periodic table, according to that data, atoms are actually getting smaller, and they're attracting electrons more. So then if you move to the left, it's just the opposite. Atoms are actually getting bigger, and they're attracting electrons less. So if you look at the data, that's what it tells you. It doesn't tell you why, just that's what the data tells you. Okay, so pause, partner read the next page, and then we'll go over this one together. Alright, it says, from side to side on the periodic table, what factor inside the atom is the most important to determine atomic radius and electronegativity? Alright, so I'll type this one out. So we're going to say the protons in the nucleus are the most important factor because more protons will attract electrons and thus draw the electrons in, decreasing the atomic radius. And of course, if we're attracting electrons more, that's directly related to electronegativity, because our definition was how well atoms attract electrons is electronegativity. Alright. So again, pause, unpause when you're ready to go over the next one. So you just did side to side, now you're going to go up and down. So now you're going to do groups. You just did periods. Okay, as you move down the periodic table, atoms get bigger and they attract electrons less. And as you move up the periodic table, atoms get smaller, it's just the opposite, and attract electrons more. Go ahead and read the last page. So this is the 4th one now. Partner read to each other, annotate, explain your thoughts to each other, have some good discussions, answer that question at the bottom, and then play the video for answers. If you finish this page 4, you can start doing the next page of practice with your partners. Okay, so let's go over this. From bottom to top on the periodic table, what factor inside the atom is the most important to determine the atomic radius and electronegativity? Well, last time it was protons, remember? But this time, it's not going to be protons, because then our explanation doesn't make sense, because as you go down the periodic table, you have more protons, and yet it attracts electrons less. So actually the most important factor is going to be electron shells, because with more electron shells, electrons have to be farther away from the nucleus and therefore feel less attractive force from the nucleus. And remember, with the electromagnetic force, distance actually plays a larger factor than charge. Okay. Alright, so now what you're going to do is you're going to go and work on page 11 in groups, and then you can come back and work on page 12 and 13 in partners. I'm not going to go over pages 12 and 13, but I will go over page 11. So you can pause this video, work with your groups. If you finish early, just go ahead and start working on page 12 and 13. More practice is better. These are not that bad, but you do need to practice explaining these patterns, because people who don't study it, they don't do very well. Alright, so here we go. Rank the following by increasing atomic radius. So first we got to find them. So indium, aluminum, boron, and gallium are all in group 13. And we know atomic radius increases as you go down. So then we would go boron, aluminum, gallium, and indium. These are all noble gases, and we know that atomic radius increases as you go down. So here, I'll do it over here so I can write a little bigger. So we would go helium, neon, argon, krypton, and xenon. Zinc, potassium, bromine, and calcium are all in period 4. So now we're not talking groups, now we're talking periods, and we know that atomic radius increases to the left. So we start with the one on the right, so it'd be bromine is the smallest, and then it would be zinc, calcium, and potassium would be the largest. Okay, and then these are all in group 5, and again, atomic radius increases to the left, so we would start with xenon, and then iodine, and then ruthenium. That's not one you see very often. And then strontium. Okay, what about electronegativity? Well, the patterns for electronegativity are just the opposite of atomic radius, so you only have to remember one, and then just remember how they're related. So beryllium, magnesium, calcium, these are all in the same group. So electronegativity increases as you go up. So we would go calcium, magnesium, beryllium. Fluorine, chlorine, bromine, these are all halogens. Don't forget the family names. And electronegativity is still increasing as we go up. So bromine, chlorine, fluorine. Alright, sulfur, chlorine, aluminum, silicon are all in period 2. Electronegativity increases to the right, so this would be aluminum first, actually. Aluminum, silicon, sulfur, chlorine. And last but not least, 2D. These are all in period 2, and so we would go to the right, beryllium, nitrogen, oxygen, fluorine. Fluorine's actually the most electronegative because the noble gases can't attract electrons. They're already having full shells, which we'll see in our next lesson that full shells make things stable. Okay, number 3. So sodium is going to have 3 shells. 2 on the inner one. This one's full. And then 1 here. And then potassium is basically the same thing, except it has a 4th shell. The 4th shell is the one that only has 1. Okay, so let's see if I can do this without being too sloppy. And then we need 8 more. Okay, so that's potassium. What do they have in common? Well, they're both alkali metals. You could talk about some of the properties like conductivity, etc. And they both have 1 valence electron, which has a larger atomic radius. So potassium does because it has more shells. So the electrons are farther, the valence electrons specifically, are farther from the nucleus. If all you said is Oh, potassium because it has more shells. That's not good enough. You've got to incorporate the vocabulary, right? The valence electrons are farther from the nucleus. That's part of the definition of what atomic radius is. Which has a higher electronegativity? Let's say sodium, because it has less shells and so the valence electrons are closer to the nucleus and feel a stronger attraction. Alright, so remember, up and down a group, you're going to focus on electron shells. Alright, let's do this last one. So sodium I already did, and then magnesium, I think you get the idea of these Bohr models. But I'll do magnesium again. But it has 2 valence electrons. So what do they have in common? They both have 2 shells. They're also both metals, so you can talk about malleable, conductive, etc. Here though, sodium will have a larger atomic radius because it has fewer protons. So the electrons are not attracted and get farther away. I know it's really sloppy. You just gotta listen to what I'm saying. I probably should type this. So which has a higher electronegativity? We can say that magnesium has a higher electronegativity because it has more protons. Right? That's also why it's smaller. So it's the same reason. The magnesium has a higher electronegativity because it has more protons and the increased positive charge pulls in the electrons more. I know there's a typo. I'm not going to worry about it. You know what it's supposed to say. Okay, so now that you've gone over that, I want you to work on pages 12 and 13 for practice. If you finish all of that, you can work on homework. Anything you don't finish, I'm probably going to have you do tomorrow if you have extra time. Okay, pass out the exit slips. When you're ready to go over grading, you can go ahead and unpause the video, and I'll go over grading the exit slips for you. Don't do this until you only have like 10 more minutes in the period. Okay, so which is the larger neutral atom, fluorine or oxygen? Explain use of vocabulary, include a model in your answer. Easiest thing to do here is to do the Bohr model. Alright, so oxygen is a larger atom, that's a check. Since it has less protons, that's a check, but the same number of electron shells. The protons exert less attractive force, that's a check, and so the electrons do not get pulled as close to the nucleus. And then they should include some sort of model. So here I drew Bohr models. Now notice the protons is the important bit, and so make sure you have that part of your model. Because if you just draw the rings, I don't think it really lends itself to really explaining this very well. Okay, make sure to get some feedback and to do some reflection. You are responsible, intelligent students. You do not need me there to breathe down your neck and make sure you learn. So make sure you reflect on your positive and negative behavior and set goals to do even better for the next class. Have a good day.